Good morning, everyone. Very good morning to you, students. Okay, today let me discuss about the uniform flow through the channels. So, when we start the uniform flow through the channels, there are some hydraulic structures, that is the notches and weirs. And we know that the function of the notch and the weir is same to remove the surplus water. The notch, what is meant by the notch? It's a opening which is provided inside of the tank or a reservoir, but it is used to measure a small stream, thus discharge through a small stream or the canal. And we also done the laboratory experiment using a notch. So here we know that is the notch is a the hydraulic structure, or it is a opening which is provided in a side of the tank to measure the discharge of the water through a small streams or the reservoirs. And so here what is, and the important technical term in the notch is sill or the crest level. What is the sill? It's nothing but it's a bottom edge of the notch, and over which the water flows. The whatever the water flows over the crest or the sill level, we call it as a what? It's a nappe or vein. And a notch is usually made up of a metallic plate, and it is used to measure the small discharges. Whereas the weirs, which is used to measure the large discharges, and it is made up of a concrete or the masonry. And there are some classification in the notches, and the types of notches are rectangular notch, triangular notch, trapezoidal notch, and stepped notch. These are the types of notches. And discharge over rectangular notch. So let me discuss what is the expression for discharge over a rectangular notch. So here we can see that water surface. So whatever the showing the H, that is a water surface, that we got as a nappe or the vein, that is VEIN. The sill or the crest level, it is, I think it's very clear here, that is a sill or the crest level. So here, that is a sill or the crest level. So we know, so here we can easily see that there is a crest or the cell level, and the water surface is nothing but the nappe, it's shown clear, and it's a rectangular section. So when the water flows over a rectangular section, so what is the expression? So now we are going to derive that expression for what is the expression for the rectangular notch. Okay, let me move to the next slide. To derive the expression for the discharge over the rectangular notch, so what we have seen in the diagram, the 1 is the height of water above the sill of the notch, and L is the length of notch or the weir, and the CD is the coefficient of discharge. So let we know that the H is the height, L is the length, CD is the coefficient of the discharge. Then how can we derive the expression? First, let us consider a horizontal strip of the thickness, the DH, small dh, at a depth of d. So I will show you here. Look at here. The thickness will come in a rectangular box. There is one, the strip, that we call it as a small strip. In that small strip, there is a dh, small dh, that is the thickness of the small strip. And L is the length, dh is the small thickness, and it shows small h also, that is a height. That is a small h and dh and the length. So here, look at here. Let us consider a horizontal strip of water of thickness dh at a depth of h from the water level as shown in figure. Yes, okay. Then let me consider what is the area of the strip. Whatever the small strip in a rectangular box, so that we can take it as a what is the area of the strip. What is that area of the small strip? The length is there, dh is the thickness is there. So it is L into dh. And what is the formula for the theoretical velocity? So we know that is theoretical velocity v is equal to root of 2gh. Yes. Then what is the discharge equation? That is a basic equation. Discharge equation, q is equal to a into v. That means the area into velocity. What is the area of the strip? That is L into dh. What is the theoretical velocity? That is v is equal to root of 2gh. And what is the discharge? Q is equal to L into v. That is, and dq, the discharge through the strip is dq is equal to CD is the coefficient of discharge. CD into area of strip into theoretical velocity. That is, the equation is CD into L into dh into root of 2gh. So, okay, then the discharge over the rectangular notch. Look at here, we are integrating the same equation whatever we obtained, that is the dq is equal to CD into L into root of 2gh. CD into L into dh into root of 2gh. That let we integrate from 0 to h. Look at here. So when we integrate the equation from 0 to h, the CD is the CD, the value, it remains same. The CD into L into root of 2g remains same, but we have to integrate to h into dh from 0 to h. So h, the square root of h is nothing but h to the power of half into dh. When we are integrating that h, that is h to the power of half plus 1 divided by half plus 1 from 0 to h integration. Then after integrating the h into dh, the value becomes CD into L into 2g remains constant while integrating the h. So small h to the power of 3 by 2 divided by 3 by 2, 0 to h. Now the equation, the final equation becomes that 3 by 2 becomes 2 by 3 when we put it into the, that is above, that is a ratio. That is 2 by 3 into CD into L into root of 2g into h to the power of 3 by t. So this is the expression for discharge through a rectangular notch. This is the expression for discharge through a rectangular notch. What is the expression? Let me discuss what is the expression. Q is equal to 2 by 3 into CD into L into root of 2g into h to the power of 3 by 2. So this is the discharge equation for the rectangular notch. Okay, let me solve one problem on the rectangular notch. Okay, shall we move on to solve the problem, one simple problem. 2 by 3 is constant because we have derived now how it comes, and Q is equal to 2 by 3 CD, the coefficient of discharge, it is given, that is 0.69 something, that is the CD coefficient of discharge, and the L, that is the length of the rectangular tank, and the root of 2g, g is the acceleration due to gravity, and h is the height, that is the h to the power of 3 by 2. This is the expression you need to remember while solving the problem. So let we solve one problem. Take down this problem, very simple problem. A rectangular notch of 2 meter wide has a constant head of 500 millimeter. Find the discharge over the notch if coefficient of discharge for the notch is 0.62. Let me note down what are the data given. Okay, so here I think it's very clearly visible. So here what are the data given? The one is the rectangular notch is equal to 2 meter wide. That is, a wide is nothing but the length. As a constant head is nothing but the h. It's 500 millimeter. We need to convert from millimeters to meters. And find the discharge over the notch if coefficient of discharge for the notch is 0.62. Let me note down these three data. Okay, and we know when the rectangular notch comes, so we know the expression of Q is equal to 2 by 3 CD into L into root of 2g into h to the power of 3 by 2. We have derived. So that expression you have to put here to solve the rectangular notch. Don't confusion. So here there will be a rectangular notch, V notch, as well as the trapezoidal notch. There are three types of notches we are solving in this video. So here rectangular notch, V notch, trapezoidal notch, and the expression for the rectangular notch and V notch is different. Whereas for the trapezoidal notch, there is a combination of the both, that is a rectangular notch and V notch. Okay. So here we know the expression, that is Q is equal to 2 by 3 CD into L into root of 2G H to the power of 3 by 2. And all the datas are whatever the required datas, the all datas are given here. Just we have to put the values, and finally we got the value. It is a very simplest problem. Okay, just if you know the formula for the rectangular net, just substitute the values and you will get the answer. Okay, it's very simple problem. Solve afterwards. And here one more problem. So it's a rectangular notch problem. One more. And it is little bit different here. Okay. So here let me discuss. A rectangular notch, zero point 0.5 meter long, it's clearly mentioned, it's a length is given, is used for measuring a discharge of 0.04 meter cube per second. Because in previous problem, we calculated the discharge, what is the Q. But in this problem, it is given, that is the discharge is given is 0.04 meter cube per second is given, and the length is given as a 0.5 meters, and an error of 2 millimeter was made in measuring the head over the notch. Here they are given some error. So they are given the error, that is a 2 millimeter, the error. So here what is that error? The error of 2 millimeter was made in measuring the head over the notch. That means the head over the notch, what is the height? The head over the notch, that is DH. The error in head, that means it is a DH, is equal to 2 millimeter. That means convert it into meters, that is 0.002 meters. 2 by 1000, that means millimeter to meter, 0.002 meters. Then calculate the percentage error in the discharge. We have to find out what is the percentage error, because dq divided by q. So we have to calculate what is the percentage error. And here the discharge through a rectangular notch, and here error in discharge, there will be a equation. So look at here, and it is indicated in the pink color, that is the error in discharge, that is dq divided by q. So we have to use this, dq divided by 2, dq divided by q. And we know the expression for the rectangular notch. Just substitute the, write down the equation. Q is equal to 2 by 3 CD L into root of 2G into H to the power of 3 by 2. This is the expression for the rectangular notch. And so here, and substitute all the values. Whatever you have the values, H is not given in this problem, but in the previous problem, the H is given. But here in this, H is not given. Instead of that, we have to find out H. That is, instead of that, discharge is given. So we need to calculate what is the H value. So H is equal to, so we have got some value 0.126 meters. When you substitute the discharge value, in a previous problem we calculated the discharge, but in this problem we have to calculate what is the H, because we have to find out what is the percentage error in the discharge. And after calculating the H value, that is H is equal to 0.126 meters, and here we have the percentage error in discharge can be calculated by using a relation, that is dq divided by q is equal to 3 by 2 into dh divided by h. So here there is a 3 by 2. So the expression is 2 by 3, and here it is reverse, that is 3 by 2 into dh divided by h. dq by q, that means 3 by 2 into dh by h is the expression to find out what is the percentage error. We need to remember this expression, dq by q is equal to, that is 3 by 2 into, that is 3 by 2 into dh divided by h. I think it's clear. And let me derive the expression. If you have any doubts in the problem while solving the problems and all, you can post the questions. Okay, so next let me move on to the derivation of the triangular notch. Okay, so we have to, and what is the expression for the V notch? And we know that that is 8 by 15 into CD into tan of theta by 2 into root of 2g into h to the power of 5 by 2. This is the expression for the triangular notch. Let me solve or let me derive that expression. Okay. So here it's a V notch, and the V notch, the angle is theta, and half of that is theta divided by 2. And here also we are considering a small strip. Look at there, in that V notch there is the small line, it is hatched, and that we got as a small strip, and that strip thickness is dh, and from the height is h. And whereas the capital H is the capital H is the height from the below the strip. Look at here, that is a h, and here it's the small h. Okay. So next we'll move on. So here the tan of theta by 2, look at here. So look at here, the tan of theta divided by 2 is equal to ln divided by, the ln is the horizontal distance, divided by the ln divided by what the expression on. So look at here, the ln divided by on. So ln is the horizontal distance, on is the vertical distance. Tan of theta divided by 2 is equal to ln divided by on. Then what is a ln and what is on? So ln is nothing but what? So look at here, the ln by on is equal to, ln by on is nothing but the h minus h, the capital H minus h. So look at here. So look at in this triangle, the distance of this the triangle is the capital H minus the small h, because we are finding out, we are consider a small strip to derive the any expression. So we are consider the small strip. Let we first will derive the expression for the small strip, later on we are applying, so that we are considering a small strip that thickness is h minus h. Okay, ln divided by on is equal to ln by h minus h. So then tan theta is equal to ln by h minus h, and ln is equal to h minus h into tan theta. And the width of the strip, what is the width? That is a lm. Look at in the figure, that is a lm, the small strip, the width is lm, l n m, whereas the lm is the width of the strip. Look at here, that is the width of the strip is equal to lm is equal to 2 times of the ln. Yes, the lm is the overall length or the width, and the 2 times of the ln is equal to, the ln is nothing but what we have derived here, capital H minus small h into tan of theta by 2, just we are substitute in case of the ln. And the area of the strip is equal to 2 into h minus h into tan of theta by 2 into the what is the thickness, that is the dh, width of the strip into the dh, that is 2 into h minus h into tan of theta by 2 into dh. And we know the theoretical velocity, that is root of 2gh, we know that. And the discharge through the strip, that is the same condition we are applying. So because area of the strip into theoretical velocity, because the basic equation is q is equal to a into v, area into velocity, so that we are applying here the basic condition, that is dq is equal to cd into area of the strip into theoretical velocity. Now substituting the area formula, then theoretical formula, and cd. So now we are going to integrate same the steps and the same procedures. So little bit difference in deriving the expressions. Okay, the total discharge over the whole notch. So why we are integrate? So whereas in a rectangular notch as well as in the triangular notch, why we are integrating? Because we are derive the expression, that is the dq, it is only for a small strip, whereas when we applied it for whole notch, look at here, the discharge over the whole notch may be found out by integrating the above equation. So why we have to integrate? Because when we are convert the small strip equation to the overall notch or for the whole notch, so we have to integrate. So just from 0 to h we are integrating same cd into 2 into h minus h into tan of theta by 2 into root of 2gh into dh. And let me take the constant values to this side. 2 into cd root of 2g tan of theta by 2, integrating only to h value, that is h minus h into root h into dh. So let me integrate, and I think you know the integration. So here, that is integrating of capital H into h small h to the power of half minus the h to the power of 3 by 2. While integrating, we'll get the equation, that is 2 into cd into root of 2g into tan of theta by 2. So then 4 by 15 into h to the power of 5 by 2, and you have to take the LCM here after integrating, and the final expression becomes 4 by 15 into h to the power of 5 by 2, and here 2 is there into cd root of 2g. The final expression, it becomes 8 by 15 into cd into root of 2g into tan of theta by 2 into h to the power of 5 by 2. And this is the expression we have used in a laboratory to determine what is the discharge through the triangular notch. So we know this expression, and now we are capable of deriving how the expression comes. Now we are derived, that is 8 by 15 into, that is discharge over a triangular notch capital Q is equal to 8 by 15 into CD into root of 2g into tan of theta by 2 into h to the power of 5 by 2. Yes, we have derived now. And for right angled V notch, if coefficient of discharge is 0.6, and here, so if the notch is but in a laboratory we have conducted for the 60-degree notch, and if it is a V notch, then the tan theta by 2 is equal to 1. If the theta is equal to 90 degree, then tan of theta by 2 is equal to the 90 degree divided by 2, the tan 45 degree is equal to 1. And the CD value, if it is 0.6, if the CD coefficient of discharge value is given as 0.6, and if it is a right angle triangle, then the final expression, because all the values are constant, if it is a 90 degree, then tan 45 degree is equal to 1. Then coefficient of discharge is 0.6. If it is specified the 0.6 only, then the equation becomes, that is 1.417. After simplifying this, 1.417 h to the power of 5 by 2. It's very simple. That's why what is the difference between, why the advantages of V notch is more than the rectangular notch is, one is the expression. The expression is very simple, that is Q is equal to 1.417 into h to the power of 5 by 2. Whereas for the rectangular notch, what is the expression for rectangular notch? That is 2 by 3 into CD into L into root of 2g into h to the power of 3 by 2. What is the expression for V notch? V means that is a right angled V notch. So here advantages of the right angled V notch is more than the rectangular notch, because the expression is simple, because if the theta is equal to 90 degree and the coefficient of discharge is 0.6, then the expression is simple, that is Q is equal to 1.417 h to the power of 5 by 2. If the angle is different, that means if the angle is 60 degree, then we have to use which formula? That is 8 by 15 into CD into root of 2g into tan of theta by 2 into h to the power of 5 by 2. That formula we have to use. If it is a right angle triangle and the coefficient of discharge is 0 point, then only you have to use the simple expression called 1.417 h to the power of 5 by 2. Otherwise, if the angle is different, if the coefficient of discharge is different, then you have to use the 8 by 15 into CD into root of 2g into tan of theta by 2 into h to the power of 5 by 2. I think it's clear. Okay, if you have any doubts, you can post the questions. Okay, next, let me solve one simple problem here. So I've just taken the simple problem how to solve. Just if you know the formula, just we are substituting the values and find out what is the discharge. Okay, find the discharge over a triangular notch of angle 60 degree. When the head over the triangular notch is 0.2 meters, assume CD is equal to 0.6. Here, a triangular notch of the angle is 60 degree. It's not a 90 degree. It's not a right angle triangle. It's a 60 degree. When the head over the triangular notch is 0.2 meter, then assume CD is equal to 0.6. Okay. So here, the angle of notch is 60 degree. So if it is a 60 degree means, so then we have to use the formula, the like Q is equal to 8 by 15 CD root of 2G tan of theta by 2 H to the power of 5 by 2. And the H is given, angle is given, CD is given. Just substitute and find out the what is the discharge Q. That is Q is equal to 8, and you need to remember the formula. So you need to remember the formulas for the rectangular is different, triangular is different. Okay, and also we know how to derive that both the equations. Let me move. Okay. The one more problem is there. The one more problem, and it's also a simple. Just take a look, and it's a rectangular channel. Okay. A rectangular channel of 1.5 meter wide. A rectangular channel of 1.5 meter wide has a discharge of 0.2 meter cube per second, which is measured by a right angled V notch weir. And also find the position of apex of the notch from the bed of the channel if the maximum depth of water is not to exceed 1 meter. So here both are given. So rectangular notch is given and as well as the V notch is given, and which is measured by, that's why we have to use Q is equal to the V notch, right angled V notch or a weir. And here look at here, why we have used this equation, because the CD is different. If CD is equal to 0.6, then we can go for the 1.417 into H to the power of 5 by 2 if CD is different. If right angled is given but whereas CD is different, then also we have to go for this expression and substitute the values. That is a substitute the values of if it is a right angle triangle, type theta is equal to 90 degrees, CD is given, and the depth of water in the channel is 1 meter, not to exceed, that is the maximum depth of water. And to find out what is the H, it is simple calculation. Don't confuse here because the rectangular channel kottidare. So here the discharge is given and the measurement, that is which is measured by a rectangular V notch, and you have to understand the concept what we have to calculate. Okay, so here we have to use the V notch formula because which is measured by a right angle V notch. So here it's a rectangular channel and its discharge is given, but it is measured by using a right angled V notch. So then which formula we are going to use? The V notch formula we have to use. That's why Q is equal to 8 by 15 CD into root of 2G tan of theta by 2 into H to the power of 5 by 2. Then substitute the value, then find out the H. Then one more condition is given. So here also find what is the position of the apex of the notch. That means the apex means that is the tip of the notch. The tip of the notch is nothing but the sill or the crest level we call it as, at the bottom of the notch anta heltadvi. So that is the position of apex of the notch from the bed of the channel is. Depth of water in the channel is given, that is 1 meter, that is it not to exceed 1 meter, it's given. And the height of water we have calculated in the V notch, that is 0.45, and this gives what is the position of the apex of the notch from the bed of the channel. I think it's clear. Okay, let me move on to the one more problem. That is problem on discharge over a triangular notch. Take down the problem, just solve. A right-angled V notch is used for measuring a discharge of 30 liters per second. So we need to calculate and we need to convert from liters per second to meter cube per second. An error of 1.5 millimeter was made while measuring the head over the notch, and to calculate the percentage of error in the discharge, take the CD coefficient of discharge is given, and here is the solution. It's a right angled V notch. Yes, we agree. And the coefficient of discharge is 0.62. So that's why we are going to use 8 by 15 into CD into tan of theta by 2 into root of 2g into h to the power of 5 by 2. And so here, and the Q is equal to 30 liters per second. Just convert it into meter cube. Here it is converted to centimeter cube per second. You convert it into meter cube per second. And the DH error in head is nothing but the DH is given. It's the same type of the problem we have solved in the rectangular section also. We have to find out the what is the error, percentage error. We have calculated in the same way. And the Q is equal to 8 because it's a right angle V notch, but the CD is different. It's a right angular V notch, but coefficient of discharge is 0.62. That's why we need to use the same basic formula. Q is equal to 8 by 15 into CD into tan of theta by 2 into root of 2g into h to the power of 5 by 2. Just substitute the value and find out what is the h. And the dq by q is equal to, so there is also a dq by 2. There we have used 2 by 3. So here, sorry, 3 by 2, that is a higher value in a hub, that is a 3 by 2. That is a h to the power of 3 by 2. So that we are used. dq by q is equal to, so here also h to the power of 5 by 2 is there. So that we have to use. dq by dq by q is equal to 5 by 2. Whereas in a rectangular section, to find out the percentage of error, so there we have used 3 by 2 into dh divided by h. So here it's 5 by 2 into dh divided by h is equal to, just substitute the value. So it gives a percentage of error is 1.77 percentage. I think it's clear. Okay, next we'll move on to the discharge over a trapezoidal notch. So here the trapezoidal notch, it's a combination of rectangular notch as well as the triangular notch. Yes, we know that. So it's a trapezoidal notch is the combination of both rectangular as well as the triangular. So that's why here it's a to derivation of the trapezoidal notch is very simple because we are taking both to and derive. So when in an examination also, when they used to derive the trapezoidal notch, this much is enough. Okay, just you have to draw the diagram and note down the notations, and finally you add up the both equations and write down. That is enough. Okay, here it's a trapezoidal notch and it's a combination of the triangular and the rectangular notch, and the sum of the triangular and the rectangular notch will give the trapezoidal notch formula. Okay, h is the height of water over the notch. Yes. L is the length of the rectangular portion. See here the coefficient of the triangular notch is different, whereas the coefficient of the rectangular notch is different. That means the CD1 and CD2, that's why they are mentioned here. CD1 is equal to the coefficient of discharge for the rectangular portion, and CD2 is equal to coefficient of discharge for the triangular portion. That's the difference. Okay. So here the discharge over the trapezoidal notch is equal to the discharge through the rectangular portion BCFE, and it is given by directly we are writing the rectangular portion equation, that is Q1 is equal to 2 by 3 CD1 into L into root of 2G into H to the power of 3 by 2. And discharge through the triangular notch is given by the equation Q2 is equal to 8 by 15 into CD into root of 2G into tan of theta by 2 into H to the power of 5 by 2. And discharge through the trapezoidal notch or the weir, it's a combination of both the discharges. Q is equal to Q1 plus Q2, and the formula is same. 2 by 3 into CD1, and here just we have to just a small correction in that, that is 2 by 3 into CD1, and here it is CD2. So that is the what the small difference in a trapezoidal notch. 2 by 3 CD1 L root of 2g h to the power of 3 by 2 plus 8 by 15 CD2 root of 2g tan of theta by 2 into h to the power of 5 by 2. So this is the expression for trapezoidal notch. Don't confused. So just we are substituting the both equation, and this much is enough for your examination also. Okay, but you have to write down the diagram and some notations explanation, and this much it is very enough. Okay, so here is a trapezoidal notch problem. Find the discharge through a trapezoidal notch which is 1.2 meter wide at the top and 0.50 meter at the bottom and is 0.4 meter in height. The head of water on the notch is 0.3 meter. Assume CD for the rectangular portion is equal to 0.62 and for triangular portion is 0.6. What is the formula? Addition of both two. Okay, 2 by 3 CD1 into L into root of 2g into h to the power of 3 by 2 plus 8 by 15 into CD2 into root of 2g tan of theta by 2 into h to the power of 5 by 2. Just to substitute, just to write down the equations, combination of both equation. And here, if the theta is not given, it's a what? Discharge the trapezoidal notch, and that means that it's a combination of both, that is a right angle notch, rectangular notch as well as a triangular notch. But here the theta value is not given. If it is a right angled, or if it is a what, it's a right angle or it's a 60-degree notch, it's not given. That information is not there. So that's why we are used to calculate the tan of theta by 2. The tan of theta by 2 is equal to, we know that, the horizontal by vertical. The mn divided by nb, just horizontal distance by vertical distance. By using that horizontal by vertical distance, the horizontal distance is equal to ms, that is the total width of the trapezoidal notch, that is a ms minus np is the what, that is the np is the what, np is what, it's a, the distance between np is the rectangular notch width, ms is the total width of the trapezoidal notch, ms minus np divided by 2 divided by nb. Total mn distance is 1.2 meter. NP distance is, what is the NP? 0.5 divided by what is the NB? The height is 0.4. That is 1.2 minus 0.5 divided by 2 divided by 0.5. Tan of theta by 2 is equal to 0.875. If the directly the theta is given, if it is a 90-degree or whatever, so then you need not to calculate the tan of theta by 2. If it is not given, so then you have to calculate what is the tan of theta by 2, that is 0.875. That, and after this calculation, just substitute and find out what is the discharge for the trapezoidal notch. I think it's clear. All the triangular notch, rectangular notch, trapezoidal notch, we have derived all three expressions, as well as we solved all three problems. Okay. Then, what are the advantages of V notch over the rectangular notch? So, one thing, for right angled V notch, the expression is simple when it is compared to the rectangular notch. That is a one case. And for low discharges, a triangular notch gives a more accurate result. If it is a low, very low discharge, the triangular notch gives a very accurate results than the rectangular notch. And in a given triangular notch, only one reading h is required. Yes, that is h to the power of 5 by 2. Whereas for the rectangular notch, L is required. But whereas in a triangular notch, only h is required. And the ventilation of the triangular notch is not necessary. It's not necessary. That is a one more advantage. And the same triangular notch can be measured a wide range of flows accurately. So it can, and so here it can able to measure accurately the results of the larger discharges as well as the small discharges. That are the advantages. These are the advantages of the V notch over the rectangular notch. So then next, what is the difference between a notch and a weir? Take a look, what is the difference? So here the Scylla, the crest level at the bottom, at the bottom of the notch, and whereas the Scylla, the crest level is nothing but the top of, it's at the top. And naturally the notches are made up of metallic plates, whereas it is made up of the masonry or the concrete. And the notches are used to measure the small discharge, whereas the wears are used to measure the large discharges. And the notches are smaller in size and the wears are bigger in size. And the definition, the notch may be defined as an opening which is provided in the side of the tank, whereas weir is defined as a structure which is constructed across a river. So these are the major difference between a notch and a weir. And let me move on to the next concept, the continuation of this. That is a uniform flow channels. The flow channels. So here, what is the channel? The uniform flow channels. So in this, the channel may be, I think it should be explained in the before that's the starting slide. So okay, what is a uniform channel flow? A channel may be defined as it's a passage through which the water flows. We know that at the atmospheric pressure as such in channel. And what is the difference? When the water flows over the pipes, it is called as flow through pipes, and the water flows through the channels and under the atmospheric pressure is called as a uniform channel flows. And the no pressure difference can be built up between the any two sections. No pressure difference is built because it's an open channel, and the flow in the channel is carried out as a result of the earth's gravity. Yes, we agree with that. But whereas in a pipe it's due to friction, and when the water flows through the pipe there will be a friction, but here it's due to earth's gravity. And for example, there is a rivers, streams, underground drains, channels, tunnels, etc. For example, for the uniform channel flows. And very important concepts in the channels are, that is a specific energy. What is this specific energy? The specific energy of the flow at any channel section is defined as what? It's a energy per unit weight of water measured with respect to channel bottom as the reference or the datum. When we take the channel reference, that is the channel bottom as a reference, what is the energy per unit weight of the water measured with respect to the channel bottom? So that is called as a specific energy. The specific energy is nothing but what? It's the energy per unit weight, when it refers to the bottom of the channel. And the equation is, the specific energy E at any section is given by E is equal to Y plus V square by 2G. Or it can also be written as Y plus Q square by 2G into A square, because we know the expression, basic expression, Q is equal to A into V, where V is equal to Q by A. That means Q square by A square. That's the difference. So E is equal to Y plus V square by 2G is the specific energy formula. Then this is the specific energy curve. So here the specific energy curve, that is a YC, Y1. YC is nothing but the critical depth. Y1 and the Y2 are these two are the different depths. And with corresponding to that, E0, E1, E2. That is a specific energy, the critical specific energy, and the specific energy. Then the specific energy curve. Specific energy curve is nothing but what? So it's showing the variation of the specific energy with a depth step. The curve which shows the specific energy with the depth is called as the specific energy curve, and the expression is same, Y plus V square by 2G, and that is equal to EP plus EK. That means potential energy plus kinetic energy. Specific energy is nothing but the potential energy plus kinetic energy. EP is nothing but the Y. That means the Z anta heltivalla, that is the potential energy, it is denoted by Z, plus kinetic energy is V square by 2G. It is same in all the formulas, that is the Z plus V square by 2G. You can easily understood by using the Z plus V square by 2G, that is the potential energy plus kinetic energy. And consider a rectangular channel in which a steady but non-uniform flow is taking place. So here the rectangular channel it's a steady but non-uniform flow taking place, then the velocity of flow is equal to V is equal to Q by A. We know that, and that can be written as V is equal to Q divided by B into Y. Breadth into depth, that is equal to Q divided by Y. And where Q is the discharge through the channel, B is the width of the channel, H is the depth of the flow, small q is the discharge per unit width, then Q is constant. Hence, that is E is equal to Y plus Q square by 2G into Y square. That means that also be equal to EP plus EK, potential energy plus kinetic energy. And it is plotted from the above equation, the graph between the E along the x-axis and depth along the y-axis is plotted will be the specific energy curve. Along the x-axis, along the y-axis. Along the y-axis, depth, that is y1, y2, y3. And along the x-axis, specific energy, while plotting the specific energy along the x-axis and depth along the y-axis, and this is called as the what? That is the specific energy curve. This is called as specific energy curve. And the specific, and in this there will be two important concepts, that is the critical depth and critical velocity. The critical depth is equal to yc and the critical velocity is vc. Critical depth is nothing but the depth of flow of water at which the specific energy is minimum. What is the specific energy? It is, what is the specific energy? Weight per, it is a weight per, what is the specific energy? What is the specific energy? So it is the energy per unit weight. So if the energy per unit weight, it becomes minimum, so then we call it as a critical depth. The specific, when the specific energy is minimum, so then it is called as the critical depth. The depth at which the specific energy is minimum. So that is the critical depth. That means E is equal to Y plus Q square by 2 into G into Y square for E to be minimum when dE by dy is equal to 0. That means the critical depth is equal to Y or Yc is equal to Q square divided by G whole to the power of 1 by 3. And the critical velocity Vc, it is defined as the velocity of flow at the critical depth. At critical depth, when there is a velocity, so that we call it as a critical velocity, and it is obtained by, and it is Q is equal to Yc into Vc. That means Yc is nothing but the critical depth, Vc is the critical velocity. The depth at which the velocity takes place, that is called as the critical velocity. Q is equal to Yc into Vc. Q is equal to Yc into Vc. And the specific energy curve, it's over. And the specific and the critical flow. Critical flow, when the Frould's number is equal to 1, that means it is defined as the flow at which the specific energy is minimum. The depth at which the specific energy is minimum is called the specific, it's a critical, what it is? Critical depth. The depth at which the specific energy is minimum is the critical depth. The depth at which at the depth the velocity taken place is called as the critical velocity, and the depth at which the flow takes place, it is called as the critical flow. And it is given by the equation, that is Vc is equal to G into Yc to the power of half, that should be is equal to 1. When it is a critical flow, when the Frould's number is equal to 1, so then it is called as a what? It's a critical flow. Critical depth, critical velocity, critical flow. And the critical depth in terms of minimum specific energy. The specific energy is minimum. The specific energy is minimum when depth of flow is critical, and hence the E minimum is equal to Yc plus Q square by 2G Yc square. So this is the E minimum expression. And hence critical flow occurs when depth of flow is 2/3 of the specific energy. So when we call it as a critical flow, it occurs when depth of flow is 2/3 of the specific energy. and there will be a the important formulas and the basic formulas for the computation of the discharge. So what are those? That is, one is the Chedji's formula and Manning's formula. So Chedji's formula, so when in the problem, if they ask to calculate by using the Chedji's formula, calculate the discharge, we have to use these formulas. Q is equal to A into V, that is the A into V is nothing but the area into velocity, whereas velocity is equal to C into root of RS. C is the constant, Chedji's constant, whereas R and the S, that is the root of R into S. And V is the mean velocity of flow, A is the area of flow, R is the hydraulic mean depth, S is the slope, C is the Chedji's constant. And the Manning's is equal to, C is equal to 1 by N into R to the power of 1 by 6. If C is not given, then to calculate by using this expression, that is 1 by N into R to the power of 1 by 6. Then what is mean by the economical? So we have discussed different geometrical sections, that is the trapezoidal, the different notches, that is a trapezoidal notch, triangular notch, then rectangular notch. But these are the economical sections. The economical sections is nothing but the sections are called as the rectangular sections, triangular sections, circular sections, trapezoidal. These are some of the sections. So in that, when it becomes economical, when the channel is a rectangular channel, when it become a economical section. When the channel is a trapezoidal channel, so at what condition it is economical? And when the channel is a circular section, and at what condition it becomes economical? So let me discuss. Okay, economical sections of the channels. A channel is said to be most economical when the cost of construction of the channel is minimum. But the cost of construction depends upon the what? Excavation and lining. To keep the cost minimum, the wetted perimeter for the given discharge should be minimum. Yes, we have derived in a rectangular channel section, most economical rectangular section, that is M is equal to D by 2. If the perimeter is minimum, then we can say that it's an economical section, that is M is equal to D by 2, or breadth is equal to 2 times of the depth. So here breadth is equal to B. For a most economical rectangular section, there will be two condition. So if we call it as a most economical rectangular section, its breadth is equal to 2 times of the depth, as well as the hydraulic mean depth or the wetted perimeter M is equal to D by 2. That is the condition. Okay, and we have already derived in a previous video, we have already derived the most economical rectangular section. So now let me discuss a most economical trapezoidal section. Trapezoidal section of the channel is most economical if its perimeter is minimum. Look at here. And there will be three conditions. That is, one is half of the top width is equal to half of the top width. What is the top width? What is the top width distance? So look at this diagram. What is the top width? B plus 2 into N into Y. So here what is a half of that? B plus 2 into N into Y divided by 2 is a half of the top width, is equal to, what is the side slope? Y into N square plus square root of N square plus 1. Look at here, the side slope is Y into root of N square plus 1, and the top width is B plus 2 into N into Y. Half of the top width is equal to one of its side slope. That is the one condition when the trapezoidal section becomes most economical. Half of the top width is equal to one of the side slope. Side slope, what is the formula? That is Y into root of N